Stop getting tricked by these. I know they all look a bit confusing, but you can simplify all of these by using one little trick. Let's start with the first one. You may have seen this before. This is called an infinite geometric series, where each term in the sum has the first term and it gets multiplied by another number that is raised to some power that gets incremented each time. So the trick with all of these problems is that the original expression shows up again within itself, and you'll see what I'm talking about in just a second. What I can do is split off the first two and then factor 1/3 from all the remaining terms as so. You'll see I have 1/3 all times 2 plus 2 to the 1/3 plus 2 to the 1/3 squared, and so on. So here's where the trick comes in. Let's just set this entire sum equal to x. And if you notice, this is equal to 2 plus 1/3 times the original sum, which is x. So what I can do is use this to create an equation, x equals 2 plus 1/3 times x. And from there, I can go ahead and solve for it pretty easily. And then we have x equals 3. In other words, this entire expression, this entire geometric sum is equal to 3. All right, guys, now it's time to get radical. Stop. There's no special name for this. It's just like a repeating sum within square roots. So I could use the same trick as last time where I set this whole expression equal to x and use that to indicate when the pattern repeats itself. So if you notice when the square root starts over, this whole expression is also equal to x. So with that, I can write the following equation. X equals square root of 15 plus 2x, all inside the square root. Now how do I solve this? I can go ahead and square both sides. I'm only going to take the positive version of this answer because I assume that this has to be a positive number. Then I can move everything on to one side and set it equal to 0. Lastly, I can go ahead and factor this. And because I want the positive answer, that means that x has to be equal to 5. This one's a bit goofy looking. We got 6 plus 1 over 6 plus 1 over 6 repeating, and so on. So I think you kind of get the gist of it now. We can set this equal to x, and notice that the expression starts to repeat itself here. So we have x equals 6 over 1 plus x. Multiply the denominator on both sides. Then we can move 6 onto the other side to make another quadratic equation. We'll factor it and take the positive answer, which is x equals 2. Lastly, we got the 9s repeating in the cube roots. We can again set this equal to x, which gives us the equation x equals 9 times the cube root of x. This is the same thing as 9 times x to the 1/3. So if I divide both sides by subtracting powers, we get x to the 2/3 equals 9, which means that x equals 9 to the 3/2. In other words, x is lastly equal to 27. So hopefully when you see an infinitely repeating expression like that, you'll know what to do. Like and subscribe for more math tips.